Hello everyone, welcome back to my YouTube channel. My name is Harshini.P.V, currently pursuing my BE in Sri Venkateswara College of Engineering, Bangalore. USN is 1VE23021. Third SEM, Section DEVO, Branch CSE Subject Digital Design and Computer Organization. Topic K-mapping and its advantages and disadvantages. Contents which we are going to cover in this video are K-mapping definition, how it works, how to use it and when to use it, some things to know about K-map, K-map is OP minimization, don't care condition, K-map POS minimization, advantages of K-mapping and disadvantages of K-mapping. Firstly, let us see what is K-mapping. A Carnot map or a K-map refers to a pictorial method that is utilized to minimize various Boolean expressions without using the Boolean algebra, theorems along with the equations manipulations. A Carnot map can be a special version of the truth table. Now let us see how the K-map works. K-maps are made up of cells, rows, columns, and you fill them with ones and zeros to create groups. The number of cells in a K-map is determined by the number of input variables and is calculated as 2n, where n is the number of input variables. How to use it? You can build a K-map directly from an expression or from a truth table. K-maps use gray code for the row and column indices instead of binary numerical order. When to use it? K-maps are best for expressions with 2 to 4 variables. For expressions with 1 to 3 variables, Boolean algebra is the best method, and for expressions with more than 6 variables, computerized methods are the best. Some things to know about the K-maps. Cells. Each cell represents the interaction of an x-axis and y-axis coordinate. The number of cells in a K-map is determined by the number of input variables and is calculated as 2 raised to the power of number of input variables. Rows and columns. The rows represents functions a and b and the columns represents functions c and d. Gray code. K-maps use gray code to order the row and column indices. Building K-maps. K-maps can be built directly from an expression or from a truth table. Solving K-maps. K-maps are solved by creating groups of zeros and ones. Inverse functions. To solve the inverse function of a function, group the zeros instead. K-maps are quicker and easier to use than other methods for simplifying Boolean expressions, especially for expressions with 2 to 6 variables. Now let us see about the K-map SOP minimization. The K-map is used for simplifying Boolean expressions to their minimal form. A minimized SOP expressions contains the fewest possible terms with fewest possible variables per term. Generally, a minimum SOP expression can be implemented with fewer logic gates than a standard expression. The three variable K-map. In the three variable K-map, there are 8 cells as shown. Mapping a standard SOP expression. For an SOP expression in the standard form, a 1 is placed on the K-map for each product terms in the expression. Each one is placed in a cell corresponding to the value of a product term. Example, for the product term A, B bar C, a 1 goes in the 101 cell on a 3 variable K-map. It can be as shown in the diagram. Let us see about the don't care conditions. Sometimes a situation arises in which some input variable combinations are not allowed, that is BCD code. There are 6 invalid combinations, that is 1010, 1011, 1100, 1101, 1110, and 11 and 11. Since these unallowed states will never occur in an application involving the BCD code, they can be treated as don't care terms with respect to their effect on the output. K-map POS minimization. The approaches are much the same as SOP except that with POS expression, OS zeros representing the standard sum terms are placed on the K-map instead of ones in every cell. Some of the advantages of K-mapping: data representations simplicity, easy and convenient to implement, reduces the cost and quantity of logical gates, less number of steps when compared to algebraic minimization technique, does not demand for the knowledge of Boolean algebraic theorems. Some of the disadvantages are: as the number of variables in the logical expressions increases, the K-map simplification process becomes complicated. The minimum logical expressions arrived at by using K-map simplification procedure may or may not be unique, depending on the choices made while forming the groups. Tedious for more than 5 variables.